At this point, we are getting close. We're getting close to solving the least squares solution for slope and intersect for fitting a line to data points that don't perfectly fit on the line. So let me just remind you where we were. We started with the quadratic error function, same thing as before. We computed the partial derivatives, and then we simplified those partial derivatives to this. Why is this nice? Well, because I've isolated m and b, my two unknowns, into something that looks pretty manageable here. Why is it manageable? Again, don't let the summations intimidate you. This is just a number. The sum I over all xi squared is a number. That's a number. That's a number. So think just alpha, beta, gamma. Well, that wouldn't look too bad. That looks like a linear equation and two unknowns. And this has a different set of scalar values. That looks like a linear equation and two unknowns. So we should be pretty good. We just got to lug around these slightly complicated looking scalars. So let's see what we're going to do here. Let's focus on this partial derivative. Okay, so I have obviously two equations that I have to solve simultaneously for m and b, but let's just focus on this one. All right, let's solve this one for b. Let's solve this in the sort of old-fashioned way. We'll eventually see what this looks like in the linear algebraic framework. So let me take the nb and leave it on the left-hand side, and let me move everything else over. So this negative sum of yi becomes a positive, and then this term becomes a negative over here. Okay, and so let me just get rid of that pesky n over here. So b is equal to 1 over n times this. So if you give me the slope, then I will know what the intercept is. Now obviously what we're eventually going to do is we're going to take this, we'll plug it into here, isolate the m, solve for m, and then figure out what b is. But for now, let me just take a little breath here and see if this makes any sense at all to us. So let's go back to our picture here. So this is the b that we know. Again, it assumes we know m, which we don't know right now, but hold on to that for a second. Okay, so what is this calculating? Let's see if we can just get a little bit of intuition for this. Okay. Well, so again, remember that what we're doing is we are minimizing that vertical distance. This point is specified by xi, yi. The point on the line is mxi plus b. And that's the gap right there is what we are trying to minimize. Now let's imagine this dotted line right here and that blue point right there. So what is that point? Well, that point is just mx. There's no offset, right? I'm not allowed to push it up. All I'm allowed to do is multiply it by the slope. And so the difference here between where the point mx shows up and where the point mx plus b showed up is that little gap right there. Yeah, that's all it is. Sure, that makes sense. What does an intercept do? It just allows you to move the points up and down. Yeah. Well, let's look at this equation now. So what is b? Well, imagine we're just looking at one point. It's yi minus mxi. Right? Imagine n is 1. Well, it's yi minus, oh, right. So what it's saying is once you know the slope, all the points will lie, just below where they need to be, and then that intercept just does what? It just pops you up a little bit. And you can see that's exactly what it's doing. It's looking at the gap between the y coordinate of the point where just the slope tells you it is, and that difference is how much you're going to pop back up in order to get the intercept that you want. That's a nice intuition. That sort of makes sense for us. Okay, good. Now let's go back to where we want to be. So I've got this, again, quadratic error function. Partial derivatives that are simplified, and now I'm going to start isolating some terms. So I've isolated b here, and now, of course, I've got, so that's good. I got b in terms of m, and this, of course, is an equation in terms of m and b. And now we're going to push that into there and start solving something. So again, this is another good entry point. If you want to practice your algebra, this is a good place to do that. Try to solve for m and b at this point. And if you don't get through that, that's okay. Give it a shot. And then when we come back, we're going to start wrapping this up.